Hello, this is Gayatri from CSC Data Science, and today my topic is voltage control crystal oscillators. I'm going to cover these topics. What is a VCXO? Typical VCXO specification, frequency, model, frequency stability, frequency pullability, operating temperature range, additional text code, packaging, outline, drawings, marking, ordering information. Yeah. What is a VCOX? XO. Voltage controlled crystal oscillator. VCXOs are electronic components or modules that provide the stability of a quartz resonator and can have a small voltage control adjustment. Quartz crystal external tutorial includes this many things. Voltage control crystal oscillators (VCXOs) find uses in many RF circuits where the stability of a crystal oscillator is needed, but with the ability to pull or adjust them by a small amount. The name VCXO comes from the fact that crystal resonators are often referred to as externals. That is, VCXO stands for Voltage Control External Oscillator. Using a VCXO enables high levels of stability of the quartz crystal to be combined with low levels of phase noise to be achieved, while still allowing the frequency to be altered or trimmed by a small amount. VCXOs give a stable output waveform which can be changed via an analog voltage input. The technology makes use of the pliability of the crystal, its change in frequency due to change in load capacitance. Voltage in input is used to vary the load capacitance of the crystal circuit within the oscillator. This gives a controllable change in output frequency that can be used to tune the device to match the exact frequency required while the circuit is active. We use the code VCXO to denote our voltage control crystal oscillator part numbers. Electrical parameters are given on the specification to facilitate the correct circuit design. Application support team can provide assistance if required. The limits in the following specification are indicative of the standard VCXO oscillator design. If a specification is needed which is outside the standard VCXO design offered, please contact one of our offices. Yes. Typical VCXO specification. Often VCXO are electronic components that are used where a small programmable adjustment of a signal may be required. For example of the reference signal with an electronic system, here the VCXO can be programmed using a voltage derived from a digital signal. VCXOs may also be used where a control voltage can be used to counteract the frequency changes caused by temperature, aging, etc. In this way, they find uses in many electronic circuit designs. 20 MHz CTPV HCMOS plus 25 ppm minus 10 to 70 C 5 volts plus or minus 100 ppm. The data in the example above is translated in the following order as shown in the slide. Frequency. Frequency is normally specified in kilohertz up to 999.999 kilohertz and in megahertz from 1 megahertz. All IQD's computer generated transaction documents follow this standard convention automatically. Frequency should be specified to 7 significant figures. If 7 significant figures are not used, we assume that any figure that might follow those given may be taken as 0. Example, frequency given as 16.6 MHz will be taken as 16.60, not 16.6666. Model. The model incorporates the following information: holder style, output compatibility, supply voltage. Frequency stability. Frequency stability of a VCXO includes initial adjustment tolerance at room temperature, with the control pin set to center trim voltage, example 2.5 volts. Stability over the operating temperature range. This value is specified as parts per million ppm and is available in ranges of, for example, plus or minus 25 ppm, plus or minus 50 ppm, plus or minus 100 ppm. Frequency pullability. Pullability is specified as a change in output frequency when the voltage control input is varied. This value is specified in parts per million and is available in various ranges. See individual models for details. Large pullability figures give a greater tunable range while smaller pullability figures give greater control. The pullability may be specified as either relative pulling or APR, that is, absolute pulling range. Relative pulling defines the actual ppm change which will be seen on the output when the voltage control line is varied from one extreme to the other and all other factors are held constant. No allowance is made for frequency shift due to other factors. This ppm change may not always be attainable when referenced to the nominal frequency. APR defines the pulling which will always be available to the customer when reference to the nominal frequency. An allowance is made for the shift in frequency due to the factors such as temperature, aging, supply voltage variations. These are subtracted from the relative pulling to give the absolute pullability range. What is the operating temperature range? Standard temperature ranges 0 to 70 degrees centigrade, minus 10 to 70 degrees centigrade, and minus 40 to 85 degrees centigrade. In general, oscillators continue to operate outside their normal temperature range with a degradation in frequency stability. Damage can result if the temperature reached are excessive. For other temperature ranges, we can and VCXO circuit. The basic circuit for an VCXO comprises a standard crystal oscillator but with an electronic means of turning or pulling the frequency slightly. This is almost invariably achieved using varactor or varicap diodes. In most VCXOs, a pair of back-to-back diodes are placed across the crystal. A reverse bias is applied to anodes of the diodes, which then act as a variable capacitor across the crystal. In most cases, a Colpitz's oscillator circuit is used. The amount by which the crystal frequency can be pulled depends upon a variety of factors, including the level of capacitance applied, the circuit conditions themselves, and the crystal. However, the frequency cannot be pulled too far because the activity of the crystal reduces as the level of capacitance across the crystal increases. If it is necessary for the VCXO to be pulled over a large range, then an indicator can be incorporated into the circuit. Yes. Additional code. If product is not standard, the letter T will appear at the end of the product specification. This refers to additional text on data sheet to identify the non-standard elements of the specification. VCXO applications. VCXOs are used in many applications. Here are a few. Temperature control crystal oscillators. VCXOs are used in TCXOs, temperature control crystal oscillators, where the temperature compensation voltage is applied to a control terminal of the VCXO. In this way, the drift can be considerably reduced, although the performance of a VCXO is still not as good as full oven control crystal oscillator. It is able to provide a level of performance better than that of a single uncompensated crystal oscillator and for much less than the cost of a full oven control oscillator. Narrowband PLLS. In another application, PCXOs can be used in narrowband phase locked loops where only small amount of frequency variation is required. Here, they are able to provide very good levels of phase noise. They may be used for signal reconstitution in this role. Other applications. VCXOs are used in other electronic designs where a stable and low phase noise oscillators is required. That can be trimmed or adjusted by a relatively small amount. Typically, these applications occur in a variety of RF designs as well as timing circuits. Using this approach, VCXO performance figures of frequency variation of around 35 to 50 ppm by volt are reasonably easy to achieve, and VCXOs with these figures are quite common. Naturally, the fact that the frequency of the VCXO can be pulled reduces the overall performance of the oscillator circuit. The phase noise performance of the oscillator is degraded because the effective Q of the resonator is considerably reduced. Additionally, the frequency stability is not as good. One of the major problems with the VCXOs is that the temperature drift. As this varies over the voltage control range, it cannot be optimized for all levels of control voltage. The final design being a compromise, this when used without other forms of temperature compensation. They may drift more than other forms of crystal oscillator. Specifying VCXOs. Many VCXOs are ordered as modules from a specialist supplier of these items. It is necessary to specify them correctly to obtain the required product. When specifying a VCXO, the following parameters are normally needed: frequency, frequency stability, output, operating temperature range, and deviation or pullability, transfer function or slope pullability. Frequency. This is normally specified in megahertz as discussed before. Frequency stability. Even though VCXOs are variables, the basic frequency stability still needs to be specified. Generally, this is done for room temperatures, 20 degrees centigrade, and with the voltage control point set to the center value. The frequency stability is taken for operation over the operating temperature range. The value is specified in terms of parts per million, ppm. Standard stability specifications are typically plus or minus 25 ppm, plus or minus 50 ppm, and plus or minus 100 ppm as discussed before. And the output. Transfer function or slope polarity. Although it is more normal for there to be an increase in frequency for an increased input control voltage, this is not necessarily always the case. When selecting these electronic components, it is always necessary to check the polarity of the slope. Positive means and a positive change in voltage will cause the frequency of the VCXO to move higher, while a negative slope means a negative change in voltage will cause the frequency to move higher. Supply voltage. It is necessary to specify the supply voltage for the VCXO to ensure that it operates with the supplies available within the electronic design. Also, check on the tolerance of the supply to ensure that there are no mismatches in tolerance. Often, any voltage regulator will be able to provide a tighter voltage specification than the VCXO needs. but it is always worth checking during the electronic design phase so there are no nasty surprises later. Supply current, phase noise, output configuration and drive capability. Different VCXOs have different output circuit configurations. It is important to check that the output will satisfactorily interface with other elements of the electronic design: impedance, capacitance, capability, impedance, configuration, and the like. Phase noise. Phase noise consists of small random perturbations in the phase of the signal, that is, phase jitter. These perturbations are effectively phase modulation and as a result noise sidebands and are generated. These spread out either side of the main signal and can be plotted on a spectrum analyzer as a single sideband phase noise. Package. VCXOs are electronic components that are often used in a number of areas of RF design. Voltage control crystal oscillators can be bought as small modules from many crystal resonator and crystal oscillator manufacturers, and typically a wide range is available. Custom designs can be also manufactured by more suppliers as well. During the manufacture of the overall electronic equipment, these VCXO modules can be treated as ordinary electronic components, making them easy to handle. VCXOs are normally the packaging. Tape and reel packaging is standard for most of our products. Unless individual data sheets state tape and reel packaging items will be bulk packed. Only complete reels are sold. Packaging options: bulk packed, reel, tape and reel packed, cut tape, tray pack. Now the VCXOs are widely available and most are low cost electronic components while still providing an excellent level of performance within a wide variety of electronic designs. Thank you. With this, I am ending this PPT in which I have discussed about VCXOs and their products and everything. Yeah, thank you.